Weather forecast for February 25th, 2003 by AJ. February 25th, 2003. Well, as you can see, there are two high-pressure systems. One high-pressure system is in Washington, Idaho, Montana, and Oregon. The other one is in Illinois and Iowa and Wisconsin. All this high pressure brings clear skies, but one low pressure in California and Arizona and Nevada bring stormy weather or precipitation. A high pressure system is a whirling mass of cool, dry air, generally bringing fair weather and cold, light winds. A low pressure system is a whirling mass of warm, moist air that brings stormy weather. As we see on the other map, we also have some fronts we need to look at. There are one stationary front over in California, Nevada, in Utah. They all point into Mexico, forwarding precipitation and cold and warm weather on different parts of this country. We have another stationary front up in Canada, which is pushing cold air this way and pushing warm air this way. So right in the middle we get precipitation. A stationary front is stalled with a little forward movement. Weather may remain for several days depending on the location. We don't have any warm fronts though. We only have cold fronts or stationary fronts. One of the biggest cold fronts I can see is this one, pointing down into California and the Gulf of Mexico and the Atlantic. A cold front is weather is changing. Cold air mass replaces warm air mass with it and moves from northeast to southeast. The air behind cold front is colder than it is in front. So where this is putting, it's going over here to push all of this warm air in. So the warm air is going below it, but on top, the cold air is going on top and pushing forward. But it's warmer than in the back than it is in the front. Precipitation is when hot air meets cold air, just like a stationary front, but it doesn't last as long. It usually lasts 2 or 3 hours. The rain is usually cold and solid, or liquid. Either way, it is warm on the outside, but it's cold rain. This ties up with everything like fronts, pressure systems, isobars, air masses, which I will get to later on. Isobars are anything lower than 1013 in this picture is a low pressure system. Anything higher is a high pressure system. They are connecting similar pressure points and showing where they are and the way they are located. So far, there are 3 pressure systems. One in California, one in Canada, and the other one in Greenland. All of these pressure systems show that all these pressure systems have either 552, 554, and 5 46. All going up from the low, so it goes from up, up, and then up. All going until it gets higher and higher, and then it reaches the point where it's 1013, which then it would be a high pressure system. But that is not shown in this map since it is a cold day. On February 25th, 2003, it was 10 degrees. Temperature is a comparative object measure of hot and cold. It is measured typically by a thermometer through a bulk behavior or thermometric behavior. Detection of heat radiation or a particle velocity of kinetic energy, but it might be bitcolorated in any of various temperature scales: Celsius, Fahrenheit, Kelvin, etc. Different air masses which affect North America as well as other continents tend to be separated by frontal boundaries. In meteorology, an air mass is a volume of air defined by its temperature and water vapor content. Air masses cover many hundreds of thousands of square miles and adopt characteristics of the surface below them. They are classified according to latitude and continental or maritime source regions. Colder air masses are termed polar or Arctic, while warmer air masses are deemed tropical. Continental and superior air masses are dry, while maritime and monsoon air masses are moist. Weather fronts separate air masses which are different density, temperature, and moisture characteristics. Once an air mass moves away from its source region, underlying vegetation and water bodies, quickly modify its character. Classification schemes tackle an air mass and characteristics as well as modification.